So I'm very excited today to have Sally Thompson giving us this talk. So the title, for those of you who haven't read it, is about improved prediction and management of urban shallow groundwater, and this is a win-win for developers, homeowners and the environment. This is a talk that shares some of the research of the CRC for water sensitive cities and a particular project that was looking at how we develop better in areas of shallow groundwater, because we know that it's a bit of a challenge on the Swan Coastal Plain. So welcome everybody to today's webinar. I would like to acknowledge the Whadjuk Noongar people as the traditional custodians of the land on which I'm sitting at the moment, but I do recognise that there's probably a whole lot of people sitting on different lands, so recognising that the strong connection that Aboriginal people have to their culture and specifically to water. You know, water is such a strong part of Aboriginal culture, so hi to everybody out there in different places. So as I said before, everybody's jumping on now, which is great, but yeah, thanks Celia for showing your face there. So it's just nice for Sally to have people to talk to. But if you do start losing bandwidth, then we recognise that you can turn your computer off or your video off. So I think I've acknowledged the traditional custodians, but I would probably also like to acknowledge the New Waterways Board and the partners that we have, which are a fabulous group of agencies. The Department of Water and Environmental Regulation, the Department of Biodiversity, Conservation and Attractions, the Department of Planning, Lands and Heritage, the West Australian Local Government Association, the Urban Development Institute of Australia, West Australia branch, and the Water Corporation, who are fantastic partners today of New Waterways. I would also like to acknowledge Hydropolis. So Stormwater WA first got Sal to talk about this and give this brilliant presentation. And the reason we're giving it today is it was voted one of the top presentations of the day. And so everybody said, look, we want to hear Sally speak it again. So what I'm going to do now is, and for those of you, no one has jumped on the chat. So I can see all your names. I hope everybody can see everybody's names, but say hi to people. So I know Sally's going to talk, but you know, I know there's a lot of you out there. I can see you all who know each other. So say hi and you know, tell everybody how good your weekend was. No, I'm kidding. But also at the end of this presentation, we will be having questions. So if you think of something as we're going, please feel free to pop it into the chat. We won't get Sally to answer as we go, obviously, because she'll be presenting, but at least then we have a list of questions to ask at the end. So welcome everybody. And thanks again to Sally for giving this presentation. So Sal, over to you. So feel free to share your slides or do whatever you need to do.
All right, I'm doing that. Can everybody hear me and see them? Because of course the problem is as soon as I do start sharing them, I no longer see what's going on. And what I'm now going to do is just jump into full screen mode there. Could someone just confirm for me that you're not seeing anything radically inappropriate and that this looks like a presentation at your end? Or that you can hear me?
Yeah, it's all good from my end.
Hooray, thank you. Unfortunately, I can't see anybody's faces in spite of Shelley's entreaties to turn your cameras on. So if I sound like I'm suddenly drifting off into space, it's probably happening. Shelley, thank you so much for the invitation to give this webinar. And for those who've joined us online, as Shelley intimated, this was a talk that was first given in November of last year at the Hydropolis conference, and which reflects on some of the things that a group of 4 of us learned. Oh my goodness, do you know what I've actually realised? This is the final slide in my slideshow, and it looks just like the first one. Let's try that again. It was not all good. I was fooling myself and you. Sorry, everybody. The reason I realised that that was the final and not the first slide was that I wanted to acknowledge my co-authors, whose names should have been at the bottom of the slide as they now are, specifically Greg Claydon, Dr. Margaret Shanafield and Dr. Anna Monero, who formed an expert panel to consult with industry, with academia, with local governments and with stakeholders and stakeholder groups who are engaged with the issue of land development and stormwater management in Perth. Now, since we gave this presentation in November, some of this work has been published, and although I'm sure no one will have the time to write down any URLs here, You can read more about this in detail in the Australian Water Association's water source and also in the conversation. So there's a bit of backup material if anyone wants to go a bit deeper. As you've heard, we are going to talk about urban development in the context of shallow groundwater today. And this is often a problem which, when we think about Australia, leads to people looking at Perth with a bit of side eye and saying, gee, that's a bit of a weird place. This groundwater interaction with stormwater creates conditions that within Australia are reasonably unique among our capital cities. What I want to share with you before we get going, though, is that while this may not be a common situation in Australia, it is far from uncommon globally to have urban centres located in regions which are likely to have shallow groundwater. So mapped in blue, we have areas where there is a local superficial or unconfined aquifer. Mapped in red are parts of the globe where the depth to bedrock is known to be less than 10 metres, so that we can imagine that perching of groundwater above this bedrock could occur. And in black, we have the world's largest cities. And what we find when we analyse this map at this very sort of crude scale is that about 40% of the major global cities are located in areas which are predisposed to having shallow groundwater. And what I think this means for us is that there's opportunities to learn from around the world, but there are also opportunities that if we can move to a real best practice paradigm in Perth, that what we learn here can be shared in a more global setting. So why is Perth such a weird place? Well, I can't resist getting a little bit university professor on you all and insisting that it's really a function of geology and geomorphology. So Perth, as I hope most of you might know, is located on a sand plain known as the Swan Coastal Plain. And the boundaries of this are the Indian Ocean to the west and a fault known as the Darling Fault to the right, to the east. And as we move east of the Darling Fault, we move onto the very ancient, indeed Precambrian rocks of the Yilgarn Craton, which is the geological formation that you might know as the Great Western Plateau and occupies about a third of the nation. Now, the Darling Fault represents one of the places where the supercontinent of Gondwana was ripped apart. And the other side of that divide is still known to us today. We find it in northern India, where it forms what we would recognise as the Himalayas. Things are a little bit less dramatic here in Perth, and what we've seen mostly happen at the Darling Fault is a long history of river formation coming off of the continent, and then that interacting with the deposition of sediments by the Indian Ocean to form a series of coastal dunes which progress from the very oldest, which are nearly 1 million years old, right next to the fault, to younger dunes that were formed really around the glacial and interglacial periods as we move closer to the coast. And then the rivers have continued to flow and interact with those dunes, and of course that causes them to slow down and to deposit the sediment they carry, so that the other thing we see on the coastal plain is at the foothills of this escarpment and in the floodplains of the rivers, the deposition of colluvial and alluvial material that are known as clays to us colloquially. So it's within all of these sediments that Perth's aquifers form, and they tend to flow mostly from the east to the west, sort of following the slope of the land down to the ocean. And as they do so, they intersect with the topographic highs and lows created by that dune system. So here we've got the Swan Coastal Plain, and it's been rotated so that north is to the right-hand side of this image. And what we can see in light blue are chains of wetlands that broadly run north and south and which are following the swales in between these dune systems. So this is where the water table has come up to the land's surface. And for this reason, we often in Perth refer to the wetlands as being windows into the groundwater, whether those be at permanent wetlands where we always have surface water, in areas where the water table only seasonally rises above the land surface, forming these seasonal wetlands, and also these areas over the poorly drained clays, where you can see in the photograph that things are really flat, they're really poorly drained, and there's very little storage in the soil. so that here we get seasonal inundation that can persist for really long periods of time. So this is where we decided to build a city. And the way that we've been doing this is to primarily build on the crests of the dunes, which makes plenty of sense because these dune crests are very well drained, they have lots of clearance to the groundwater, and they're really a very unchallenging sort of a development environment. And this has been going on now for quite some time, but we're running into troubles. And the troubles are that these really prime developmental sites that are so easy to work with have largely now been built out, so that new land releases around Perth are increasingly occurring in areas subject to high groundwater, whether that's on the clayey areas as we move into the northeast and to the south along the escarpment, or whether it's around the wetlands and just the shallow water table in the sands. So this creates a number of challenges for urban development, primarily that we need to have our urban infrastructure sufficiently separated from groundwater in order for that infrastructure to fulfill its roles. So we have many specifications, perhaps most significantly for minimum clearance levels between roads and the groundwater. And in order to achieve those separation distances, what we usually see is drainage of the groundwater installed beneath the roads. And so that's called out in red here as so-called subsoil drains. So these are really just permeable pipe that allows the infiltration of groundwater into a piped drainage system. We also, of course, do need to maintain sufficient separation distances between the groundwater and other parts of the urban fabric, whether that be playing fields that can't get too squishy or housing areas. And there is a degree of guidance that's provided for what these separation distances should be, put out by IPWEA, so that's the Planning Association, which are largely being used and which particularly focus on the peak of the groundwater mound, which is often called the phreatic crest, and how far that needs to be from specific urban features. One of the most problematic of these is really thinking about the separation and clearance to building foundations, because this impinges upon the geotechnical classification of sites and therefore the level of engineering that's required in the housing foundations. And so what we're really looking for, or what the development industry would really like, would be to develop so-called Class A sites where moisture changes are happening far enough away from the land surface that they can't cause any ground movement. And very often, to achieve this is going to require modification of the site as an alternative to moving to more intensively engineered construction. We also, from a stormwater and water management point of view, do need to think about what shallow groundwater means. And it really means that often there's not a lot of space under the ground in which to do things like achieve fall for our piping. So whether we're thinking about creating functional hydraulics for just getting our wastewater off-site, or for our immediate management of drainage from roofs or roads, or whether we're thinking about the additional demands for fall that are created as we start to bring water treatment features, and particularly water-sensitive urban design type features, into the developed landscape, we often find ourselves being constrained by how much fall can be achieved before you start to hit the water table. So this has meant that in many developed sites around Perth, we've needed to create more space. And the approach that we've taken, we could say, has really been to make our own sand dunes by importing sand fill. And so here's a very attractive photo of me with my nice pink hat, staring down an area of imported sand fill in the eastern suburbs of Perth. And I know it's jolly hard to see on the photograph, but an estimate of what the fill level would be here is about 3 to 4 metres worth of fill to elevate the site above what is a little floodplain for a creek that you can see on the right there. And there's the attractive view of the same development site as we look in the other direction. Okay, so this is what we're doing. Why is it problematic? There's a few issues. The first is that the importation and use of fill is economically costly. And what we understand based on the numbers from when we were consulting around this, which is now probably 18 months old, and I suspect things are worse now, is that fill could comprise up to 1/3 of the developed cost of lots. To put it another way, the cost per cubic metre of clean sand fill in Perth was 18 months ago around $30 per cubic metre. Now, why does this matter? Well, this matters because the developments that we're looking at are on the urban fringe, and they're places where first home owners or people who are just coming into the financial ability to own their own home are looking to buy. So this is not an area with great financial leeway. Instead, it's a part of the city where small changes, small increases in the cost of housing mean that potential home buyers are unable to secure a loan or to afford a property. So we can actually draw quite a tight connection between issues of housing affordability and their social repercussions and the really extensive use of expensive fill, because it's such a large part of the development cost. It's also not an environmentally benign thing to be doing, to be carving up sand dunes in one part of the world and dumping their sand in others. There's very extensive areas that need to be cleared and quarried and in order to obtain this fill. And increasingly, those are located a long way from the city, so that equally significant haulage and carbon emissions can be tied to the use of fill. Now, I don't have any good numbers on this, but what we can say with confidence is that the more sand we're moving, the greater those sorts of costs are going to be. We also achieve something quite strange at large scales as we think about the use of fill, which is that the developed landscape we create doesn't necessarily adhere any longer to an environmental, geomorphic or hydrological logic. And this is one of those things that you never notice until someone points it out to you. And now when I drive around the outer suburbs of Perth, all I can see is this sort of jigsaw puzzle of different land levels associated with different developments having taken different approaches to how they use fill. So I've started calling these Frankenstein landscapes, which have aesthetic and presumably environmental consequences. We don't know a lot about those environmental consequences, other than clearly that erosion at the edge of fill can be one of them. But presumably, when we have only 30-metre buffer distances that have previously been required between this sort of land elevation and streams, wetlands or other sensitive areas, there's plenty of scope for sediment movement, as we see here, for weed growth, but also for local groundwater mounding inside our filled areas to start changing the gradients and the flow of water in this very groundwater-driven area. Another issue with our Frankenstein landscapes and all this cutting and filling is that it compounds Perth's existing problems of removing every skerrick of vegetation prior to developing urban areas. And the reason, of course, is that if you need to raise your land surface by a significant margin, it's almost impossible to keep any existing trees alive because they are growing in a land surface that's quite different, and trees in holes doesn't work too well. Finally, what we see in these Frankenstein landscapes is that our remnant vegetation, our wetlands, our protected environments become almost completely surrounded by a landscape that's now had its surface elevated above what that previous landscape was. And again, we don't have a great understanding of exactly what this is doing, if anything, to hydrologic flow paths, to the quantity and the quality of water that might be moving between the urban and the natural environment. So there's a lot going on here with fill. And that, of course, is only thinking about what happens if we are adequately managing groundwater with it, because the flip side of this is what happens if we get things wrong. And what happens if we get things wrong, of course, is that water comes up to the land surface with consequences that may be relatively minor, in the sense that your chickens become aquatic or that your playing fields are submerged, but can also have really significant costs for homeowners whose property becomes damaged, or for developers who, as you can see on the bottom right here, maybe didn't think quite hard enough about their groundwater before starting to get their foundations in. So there are significant consequences for getting things wrong, and it's costly to remediate. Now, this image does not look like an image of things going wrong. The one clue that there have been difficulties here is circled in white, where we can see iron staining from where groundwater has been seeping out between the pavement there. But in fact, this intersection's been rebuilt completely on at least one occasion because of groundwater damage, which can be attributed to the stormwater engineering not having worked out quite right there. And rebuilding intersections like this comes at costs that approach $1 million and are borne by local government agencies. Here's another example of remedial works, this now in the east of Perth. Here it was the public open space that was routinely flooded due to groundwater. And in order to create some storage for that water, they've excavated what was green space and put in this detention basin. And I think, quite apart from the capital cost associated with this, it's pretty hard to view this as an aesthetic improvement or an improvement for the safety of the children who are playing in the neighbouring park. So we have really significant costs that attend to getting things wrong with managing our groundwater. So really, I would argue that Perth faces a paradigmatic choice between a current paradigm of managing groundwater, where we modify the existing land surface and then remediate where things go wrong. So we use conservative separation distances, we import a ton of fill, and any problems that pop up, we correct on this as-needs basis. It's really what we're doing right now. But could we shift to a slightly different paradigm where we aim to minimise the use of fill, but aim for more resilient design of our urban area? So if we're going to minimise fill, we need to look at what our best practices would be for determining what's the minimum quantity of fill we can use. And if we're going to be resilient, then aspects of our urban design need to accommodate the potential for high groundwater. So let's look at what it would take to get us into that new paradigm. And I'm going to argue that it would need some technical shifts, it would need some governance shifts, and it probably requires some cultural shifts as well. Technically, there's a few things we can do, and I'm not going to dwell on them in great detail because it sort of gets us into boring technical detail. But one would be to have more consistent approaches for how we identify the risks associated with shallow groundwater and associate those with particular development sites. And something like this, a relatively rapid site rating scheme that then prompted different assumed levels of assessment and monitoring and modelling, would be really helpful for decision makers in deciding whether proponents are addressing the risk of groundwater with the right level of care and detail. We obviously, if we're going to work out how to minimise fill, need to be able to make predictive models of what groundwater will do in the developed landscape. And there's certainly a lot of modelling out there, and there's some really good modelling, but one of the things that pops up again and again as impeding people's ability to make the best predictions possible is really just the parameterisation of those models and the need for better numbers. One area where we can make immediate improvements is how we represent the hydraulic conductivity of this fill. And there's a really clear need to actually measure this on site in the as-built condition. So that is after imported fill might have been mixed with the local soil and then compacted, rather than what we've seen or anecdotally heard about some modelling doing, which is to rely on the specifications only of the imported fill. The other area where we have a lot of uncertainty is understanding how evapotranspiration will change post-urbanisation. And the reason that's so important is that in most of these landscapes, the main way that we dry out the landscape and lower groundwater is through vaporization, evapotranspiration. And so having a better understanding of how that loss process is going to change following urbanisation be very, very helpful for improving modelling. There's also really a need in the practitioner community in Perth to be a little bit bolder in using sensitivity analysis. And just to sort of give a flavour of why this might be so important, if we do go back to the hydraulic conductivity of this fill, the rule of thumb, if you had to guess, is that the conductivity might be around 5 metres a day. But when we look at the range of things that have been measured in the field, it can get as high as even up to 70 metres a day, but it can also be significantly lower, particularly if a bit of clay gets mixed in with the sand, down at less than 1 metre a day. And so when I see reports and consultants telling me about how they've varied their hydraulic conductivity by plus or minus 5%, when the actual range spans orders of magnitude, there's a need to think a little bit harder about how well we can constrain those numbers and how much we might need to plan for those numbers being wrong. And then I guess the final thing I'll just point to technically is that at the moment there's a real lacuna in terms of technical guidance for situations where stormwater and groundwater are as intimately related as they are in Perth. And so if we pick on Australian rainfall runoff as, you know, everybody's favourite piece of design guidance, and I don't say that sarcastically, I think AR&R is a wonderful document, but it's a wonderful document that does not at all address the potential for groundwater to be a part of stormwater. You can sort of do a find for the term groundwater in AR&R and it really pops up once or twice and not in the context of what shallow groundwater might mean for runoff. So there's really an absence of a consensus-based standard for what's best practice when we have shallow groundwater in the mix. But leaving that sort of technical and modelling stuff to the side, I think we also need to think about how we design for the fact that high groundwater could impinge upon our urban landscape. And one of the really exciting things about being involved in this project has been learning about how much innovation and how many good ideas are out there, even only within Perth in our practitioner community. There's real appetite for thinking about how to do things differently. And if we look around the world, we can find lots of examples of backyards that have been built to accommodate high groundwater or even make a feature of it, of yards that have been built to elevate areas of hardstand and protect them from waterlogging and maybe to incorporate surface drainage to allow any seepage to be taken off site, and of completely novel construction methods that mean that we could get out of some of those geotechnical constraints being such a big hurdle. So, for example, the image of these houses shown on this slide comes from the United Kingdom. These two houses are built within a floodplain area that does have high groundwater, and their foundations are based on screw piles, so the same sort of thing that we do for offshore oil rigs, which enable them to be sound in a situation where there is lots of wetting and drying going on beneath them. So there's lots of opportunities out there. There's much less fancy opportunities as well. So within our stormwater design, we can do things like grade underlying clay layers, so that if this is our sort of cross-section of an urban block with our drains at the road and our crest of the phreatic surface in the backyard, if we grade the underlying clay, we effectively change the direction that groundwater is flowing and end up making it flow towards places where the drains are deeper, giving us a bit more gradient and lowering that water table. We can also try things that we haven't tried before, and they might require that we think a little bit differently about who owns drainage infrastructure and who is responsible for it. But if we're prepared to say that landowners take some responsibility for this, then we can put subsoil drains in at the rear of lots with a connection out to the stormwater system at the front of lot and lower the water table in backyards in that way. Now, if we're going to do this, we need to sort out some of the legal issues. We need to demonstrate that this works and support homeowners in how to manage this infrastructure. But as far as capital goes, this is an extra pipe. It's not really enormous. No matter where we go with things technically, one thing we need to recognise is that right now in Western Australia, local government authorities are very much in the hot seat of this issue. And the reason that they're so much in the hot seat is that they sort of have to deal with the issue both coming and going. So it's local government authorities who evaluate, request amendments to, and ultimately need to approve the water management plans that are put to them by proponents. But it's also local government that ultimately usually assumes responsibility for drainage infrastructure and for public infrastructure, and so picks up the liability when problems occur. So, you know, if you do know a local government engineer, probably do blow them a kiss, because they are picking up an awful lot of responsibility here. What we hear time and again around the Perth area is that local governments find this situation to be difficult to manage, and a large part of that difficulty comes down to resource constraints and their capacity, particularly as these new development areas are becoming more and more environmentally complex. So whether it be that the engineers who are approving developments don't have specific background in learning about groundwater, or whether it be really basic issues like the local government only having one license for GIS software so that there's minimal time available or opportunities available to really look at how things plan out in space, constraints on capacity are a real problem for local government. They also face a great difficulty in that the chain of responsibility is not really linked up all that well between the design and the building phase of urbanisation in Perth. So that we see that planning approval is addressed by state agencies, that local water management plans are pulled together by the proponents, the land developments and their engineers, and that's where the local government make their approval, but that there's not often a great way to ensure that what is actually approved ends up being what's built, because it's often a separate part of local government that does building inspection and ensuring that what is built is what was planned. And consequently, this chain of responsibility really becomes broken between so many different entities, both at state level and within local government. And clearly this is going to be a real challenge in moving towards a minimum fill approach. You can see in this situation, what do you do as an approver? You say, well, I'm going to be the asset manager, I'm going to cop the liability, I'd better require really conservative planning and management. And so if we want to turn that around, we're going to need to link up these responsibilities a bit better so that someone approving a minimal fill development has confidence that it's going to be built the way it was designed, because if it's not, it's likely to fail. So overall, the picture around Perth right now suggests to us that there is an opportunity afforded to everybody if we can reduce our use of fill. But to get there, we're going to require that there be best practice applied technically. So this is by the engineers and the modelers. We're probably going to need some innovation in how we build things, in how we design things, and how we do our stormwater management. And we're going to need to take a really hard look at our planning and decision-making frameworks, hopefully to better empower local governments to make really strong decisions, but also to address something that I've barely talked about, which is the cumulative impact of all of these local government decisions and what that might mean at regional scales. So if we want to get to this minimal fill, resilient design paradigm, how do we get there from here? So I'll finish on a few sort of suggestions for what we could do. The first is that we really need to build confidence that alternative ways of doing things will still represent a good, safe investment for everybody, from our first homeowner family that are out to buy their house, right through to the land developers whose business this is. And it seems to us that the best way to do this is going to be via demonstration projects. And maybe this involves state government run projects, maybe this involves public-private partnerships, maybe this involves innovative approaches to risk sharing. But it's very clear that we need some tangible examples on the ground of new ways of doing things that work. We also have a very large untapped resource when it comes to thinking about groundwater and urbanisation in Perth, which is that all developers are required to monitor the response of groundwater for 2 years post-development. And there's presumably an awful lot that we could be learning about what's happening to recharge, what's happening to water balance, and what's happening to groundwater as a consequence of urbanisation by mining out those data sets. So here's another area where boosts to capability and capacity would be really helpful, because to the best of my understanding, most of this data is collected, stored by state government agencies who just don't have the personnel to mine it and to learn from it. So can we make better use of the monitoring that we're required to do and the data that we've already collected? We also may need to take a really hard look at our planning process. So in Western Australia, we follow a planning process which has incorporated an approach called better urban water management, which has really done a great job of getting water management plans into the planning cycle. But as we've already touched on, At the moment, that's happening primarily at the subdivision stage. So this is when land has already been acquired by developers. They've done some investment in thinking about their planning and marketing, and now they're coming down to reasonably detailed design. And now they have to think about groundwater and what it means. What we're not doing very well at the moment is bringing in the potential that shallow groundwater is a constraint on land development and letting that inform our very large-scale macroscopic planning approaches. So it seems very probable to me that there are places that might be earmarked at the moment for development where those environmental constraints are really so large and potentially so expensive to deal with that it might be better for everybody if we just didn't go there, rather than ending up needing to import vast quantities of fill in order to convert a very soggy site into somewhere we can develop. So really what that's going to mean is that we need to keep pushing water into the planning process, and I think there's a real need to do so more upstream of where it is right now. What I hope I've convinced you of, nonetheless, is that despite some of these challenges and opportunities for changes in governance and needs for reform, that there is an opportunity for a win-win-win across the development sector, the homeowner sector, and the urban environment by moving towards a paradigm where we minimise the use of fill and have a landscape that is more resilient to the presence of high groundwater. So I'll end just by thanking the Cooperative Research Centre for Water Sustainable Cities, and particularly the Integrated Research Project number 5, IRP5, the steering committee, and everybody who participated in the expert panel discussions. Thank you.
Brilliant, Sally. Thank you so much for that presentation. That was fantastic.